Head down. All right. As we get started, go ahead and turn in your speed drill booklets to page 20. Page 20 in your speed drill booklets. Have everything else off your desk. Separate pencil and a pen, which we'll get to in just a moment when we grade. Speed drill number 42 at the bottom of page 20. Just some basic stuff. A little bit of decimal in there, a little bit of fraction in there. The division problems, I should say, do work out evenly, so they're not really super long problems or anything. You have 3 minutes to get as many of these done as you can. As I always say, do the easiest ones first. Save the hard ones for last, and you may begin. Stop. All right, pencils off your desk, pens out, and exchange with the person behind you. Person in the back, bring yours to the front. Exchange with the person behind you. Person in the back, bring yours to the front. That was very good, Corey. Good job dodging both man and camera stick. All right. Sign your name at the bottom in pen as the grader there at the bottom of page 20. Sign your name at the bottom of page 20 as the grader, and these are 10 points each. 10 points each. Going across the top row, the addition problem, you add those all together, you should get 23,592. 23,592. And number 2, for the subtraction problem, subtract to get 1,522. 1,522. For number 3, multiply. This is one of the longer ones. This is one of the ones I would have put off for a little bit later. 824,912. 824,912. For number 4, those who made it that far, really wasn't that bad of a problem. Came out evenly to 105. 105. Number 5, one of the easiest ones, as long as you remember, we just multiply 1 times 1 to get 1 and 2 times 2 to get 4, so 1/4. But a very quick problem to get. Number 6, as long as you remember 6 decimal places, I felt this was a pretty easy one, 0.006412. 0.006412. Number 7, we're going to go boink, boink. Once in the divisor, once in the dividend, get 32 for your answer. 32. Number 8, annex the 0, keep that decimal lined up. Not a hard problem at all, 1.33. 1.33. Number 9, certainly one of the easier problems as well, just a quick addition problem, 1,115. 1,115. And for number 10, also pretty straightforward addition problem, 12,741. 12,741. Yes, ma'am. Repeat.
What if they forgot a comma?
Just minus a point. Yeah, if they forgot a comma, just take off 1 point. Don't mark the whole thing wrong. All right, 10 points each otherwise, and figure the score to the best of your ability. Put it in the score blank. Once you've written it there, also put the score in the spot next to where it says Speed Drill 42. Put it next to where it says Speed Drill 42 on the score page. And once you got that on there, return it to the owner, person in the front, take it to the back. Otherwise, pass it forward to the person in front of you. And owners, now that you've got your booklets back, were there any hundreds? Any hundreds? Good. We got a lane. 90s, just missed 1. Good. A few of you. 80s, just missed 2. Good. 70s. I'd say 70s pretty decent for this one as well, so not bad at all. Are there any that we need to see worked out before we get into our math lesson today? Jalen?
Number 4.
Number 4, yeah, that long division problem. So always a good opportunity to refresh long division. 60,060. Remember, you're just going to focus on the first digits here. Class, how many times does 5, or you might round it up to a 6. How many times does 5 or 6 go into 6, class?
1.
Just once. So 1, 2, 3 digits, 1, 2, 3 digits. We're going to put the 1 right here. Obviously, 1 times 572. 572. And then we just have to be careful in subtraction, right? We do a little bit of borrowing here to get 8, 2, and that cancels. Then we got to bring down the 6. Whoa. Class, can 572 fit into 286?
No.
0 times, right? So when we subtract 0, and you technically don't have to show the step, you could just bring down the next 0, but if you did want to show the step, that gets us to a 25,060, or 2,860. Then we just got to see how many times does 5 or 6 go into 28? Well, 5 would go into 28, class.
5.
5 times. If it were a 6, it wouldn't quite fit. You could try 5 or 6. I'd probably just try the 5. And when you multiply, it does come out evenly. So not a super long problem. The numbers worked out pretty nicely on number 4. Good. Any other questions on the speed drill? All right, pass those forward if you would, please, and have your books open, bless you, to page 271. I think I mentioned this on video yesterday. It is allergy season here, and so lots of blowing of noses and sneezing and whatnot. But we are not all dying. We are just dying from the pollen. So if you in other parts of the country don't understand the Georgia pollen, lucky you. All right. Anyway. All right, page 271 in your textbooks. We had homework on page 268. We also had homework on 271, but I want to start with page 271. So page 271 in your textbooks. Oh, okay, see me after class. Good, and then flip back to page 268 once you showed me that one. So I have 268 ready to go. Good. Or 269, excuse me, it's 269. There's that one and that one. Good. There's that one and that one. Good. Good and good. You were not here. Welcome back. Good and good. All right, good and other direction. Flip back page. There we go. Good and flip it over. Good. Good and flip it over. Good. Let's take a look at these together. And we're starting on page 271. So we're next to the picture of the tacos there, or just below the picture of the tacos. And it says the letters that spell the word Mississippi are placed in a jar. I'm going to go ahead and write it out here on the board. M-I, crooked letter, I, crooked letter, I, humpback, I. That's how I learned it when I was in like elementary school. Anyway, what's the probability of selecting M or I? Well, how many letters are in the word Mississippi, class? 11 total. That's always important to find that total. If you get the wrong total, you're done. All right, so how many M's in the word, class?
1.
So the odds of the M are
1
to 11. How many I's in Mississippi, class? 4. So that's 4 to 11, and it says or, so I need to add. So what's the probability here on number 27, class?
5 to 11.
5 to 11. Number 28, the probability of selecting the letter S or the letter P. Well, class, how many S's do we have?
4.
4 out of 11. How many P's? 2 out of 11. It says or, so we need to add, so we get an answer of
6 to 11.
6 to 11 for number 28. Number 29, the probability of selecting an M or an S or a P. Well, we already said M is 1 to 11. We said S is 4 to 11. We said P is 2 to 11. And again, it's or both times, class. So again, we just need to add. And we should get what for our answer to number 29? 7 to 11. How many perfect on 27, 28, 29? We got all 3 of those. Okay, any questions on any of those first 3? As long as you remember or means add, and you count the letters, right? If you counted 12 letters, bless your heart. But show your work on the quiz or test, just in case you miscalculate. That would be unfortunate. Questions on this? All right, let's go to the ands now. Number 30 says selecting the letter I, and then putting the letter I back, and then pulling out the letter M. So I and then an M. Well, we said the probability of an I is 4 to 11. We said the probability of an M is 1 to 11. But when it says and, class, we multiply. Can I cancel anything?
No.
No, but I should always try to. In this case, I just have to multiply straight across to get what for our probability, Corey?
4 to 120.
4 to 121 probability. Very good. Number 31, the probability of an S and then drawing out an I after we put the S back. Well, we said there's 4 to 11 on the S. We said that earlier. I, we've said a number of times, is 4 to 11. But when it says and, class, we multiply. So what's our probability of an S and then the letter I? Ben?
4.
Well, we said the probability of an S is 4 to 11. Pay attention, stay with me. And the probability of an I is 4 to 11. And we said since it says and, we're going to multiply. So if we multiply 4 to 11 times 4 to 11, we get
16, 22.
It's not 22, and again, not adding them, but multiplying the 11 times 11. Class?
122.
You got it, 121. 16 to 121. Number 32, the probability of selecting the letter P, then replacing it, and then selecting the letter M. Well, we already said the probability of a P is 2 to 11. We said the probability of the M is 1 to 11. When it says and, class, we multiply. And we multiply here. What do we get for that probability, Michael? 2 to 121 is correct. How many had 30 through 32? All correct. Questions on 30 to 32? Any questions at all on the 27 to 32, the question on Mississippi? All right, take a look at number 33. Read that for us if you would, Joel.
Amelia will be ordering pizza from a local restaurant. She can choose only one option from each category.
All right, and then she can choose what crust she wants, what style she wants, what meat she wants. Only one meat, that's sad. What vegetable she wants, and she only gets one, and then what cheese she wants. How many different pizzas could she make? It's like your pie, but on a really tight budget. They don't let you get like all your stuff you want, so you got to only pick one. All right, so, by the way, Bryson, if it was you, what crust would you take?
White.
White? What style?
I don't know. I'll say thick.
The thick crust? Okay, what meat?
Bacon.
Bacon, can't go wrong with bacon. What vegetable?
0, but if I had to pick, yeah, I'll say mushroom.
Let's just, I don't do the whole fungus on my pizza thing, but more power to those who do. And what cheese?
Yeah.
Just the mozzarella, the classic cheese. Okay, but how many different ways, Bryson, could you have made up your mind just like Amelia?
480.
480. How many also had 480? You had to multiply 2 times 3 times 4 times 5 times 4 to get that answer. Questions 33. All right, flip back, if you would, to page 269. And on page 269, you did numbers 68 to 73. And we were working a little coin machine. How many have seen these coin machines at the grocery store? When I was a kid, every grocery store had them. There was like a line of them right next to the exit door, so that way little kids could beg their parents to give them a quarter. So you put in the machine, try to get a gumball or a toy or something. And now I don't see them as often. They also have those little spinny rides or whatever. Little carrot, and they were always outside the door and try to get parents to drop a couple quarters in there, just trying to get the last little bit of money they could from the parents. It was smart, except parents started using credit cards for everything, so parents didn't have any quarters. And when parents stopped having quarters, there was no point having them there anymore. So anyway, but this surprise coin machine has either has toys. One of them does. Rubber balls, cars, and yo-yos, and another one has stickers of animals, flowers, and sports. All right, so the first coin machine, we'll call this machine A, has how many different things in it, class?
40.
40 total. All right, it's got 18 balls in it. It's got 10 cars in it, not real cars, and 12 yo-yos in it. And then machine B has how many things in it?
40.
Oh, also 40. That makes things easy if they're both 40. And it's got 40 stickers, 14 animals, 10 flowers, 16 sports. All right. So number 68 says the probability of receiving a rubber ball from one machine and then a sports sticker from the other machine. Well, what's the probability of a rubber ball from the first machine going to be here? Griffin?
18 to 40.
18 to 40. We can reduce it later. Probability of a sports sticker from the other machine, Griffin?
16 to 40.
16 to 40. And since it says and, class, we will multiply. If we were adding, I wouldn't cancel anything, because I like this common denominator. But we're multiplying anyway, so let's cancel stuff, Griffin.
I don't see anything.
Well, why don't we knock a 2? They're even numbers, at least. Let's knock a 2 out of those.
9 and 20.
9 and 20. And you know we can knock an 8 out of these two.
2 and 5.
You know, I can still knock a 2 out of these two.
1 and 10.
All right, so Griffin, what's the probability of getting a rubber ball and then going to the next machine and getting a sports sticker?
9 to 50.
9 out of 50 chance. That's not too bad of odds right there. It's a good chance you get the rubber ball and then the sports sticker. How many had 9 to 50 on number 68? Questions on 68. Kirsten, number 69, the probability of getting a toy car and then getting an animal sticker. Well, what's the probability of a toy car, Kirsten?
10 to 40.
10 to 40. That looks like it says cans. That says car. 10 to 40. And then the probability of an animal sticker would be?
14 to 40.
And it says and, so we need to multiply, which means we're going to do a little canceling. Let's do the easiest canceling first here, Kirsten.
14 to 40.
I was going to say knock off the zeros. But we can cancel 14 and 40. Cancel a 2 out of both of them.
7 and 2, 20.
7 and 20. So what's our probability if we also reduce the 10/40ths to a fourth?
7 and 80.
7 to 80 chance. How many had that for number 69? 7 to 80, the probability. All right, let's go to number 70, the probability of getting a rubber ball or a yo-yo. So obviously we're only interested in the first machine here, the probability of a ball or a yo-yo. Maybe we're like, I don't need a car. Or a toy car. I need a ball. I want a ball or a yo-yo, something I can actually play with a little bit more actively. And well, what's the probability of a ball, Jalen? And probability of the yo-yo.
12 to 40.
And should we cancel stuff and multiply these together?
No.
No, we need to do what? Add them. So we get 30 to 40, which does reduce down to get 3 to 4. How many had a 3 to 4 chance of a ball or a yo-yo? Okay, just ignore them. Focus on you. All right, questions on this? All right, look at the next one. Elaine, the possibility of getting an animal sticker or a flower sticker. Maybe it's Chloe, who doesn't care about sports despite all my efforts. And she likes pretty things like flowers, and she loves animals. So Chloe wants an animal sticker or a flower sticker. Probability of an animal sticker, Elaine.
14 to 40.
And probability of a flower sticker.
10 to 40.
And it says or, so we should
Add.
to get
I think I did it the other way.
Oh, you multiplied. Oh, gotta watch those ors and ands, so fix it now. You can do this in your head.
It's 24 to 40.
Take a 4 out, or actually take an 8 out.
3 to 5.
3 to 5. Reduce this all the way down there. So Chloe's got a 60% chance, right, of getting an animal sticker or a flower sticker, if that's what she wants. Somebody have that for number 71? No, number 72, receiving a car or a ball. So a car or a ball. And what's the odds of the car, Luciana?
10 to 40.
10. Oh, crash. All right.
Timber.
Stay. All right. So 10 to 40 on the car. What's the probability of the rubber ball?
18 to 40.
18 to 40. It says or.
So
Add to get.
28 over 40.
And we can take a 4 out this time.
7 to 10.
7 to 10. How many? 7 to 10 chance on number 72. Questions on 72? 73. Ben, probability of receiving a rubber ball and a flower sticker. All right, so let's take a look here. So we want the ball, and then we want to go to the other one and get a flower sticker. Ben, what's the probability of getting a rubber ball?
How
How many rubber balls are in the vending machine?
18.
Out of how many total things in the vending machine?
40.
So what's the probability of getting a rubber ball?
18, 40.
18 to 40. All right, what's the probability of a flower sticker?
10 to 40.
10 to 40. It says and, that means I need to
Multiply.
multiply. That means I'm going to cancel stuff. Ben, what's the easiest thing to cancel?
10 to 40.
And then I can also cancel a 2 out of these two numbers.
9, 20.
9 to 20. And now when I multiply across, what do I get for the probability of a ball and then a flower sticker?
7 over 20.
Well, okay, but 9 times 1 is 9. And don't forget 20 times 4 would give me
24.
20 times 4. We're multiplying. 4 $20 bills?
80.
80. There we go. 9 to 80. How many had 9 to 80 for number 73? Questions on the probabilities. Ands and ors. Anyone perfect on the homework? Got it all? Got a few of you. Anyone just missed 1 or 2 of the homework problems? Any questions at all on the homework? All right, turn over to page 271. Let's look at the bottom of the page. Number 1 at the very bottom there in the Chapter 7 Review A says, what principle states that to find the total number of outcomes for 2 separate events, the number of outcomes should be multiplied? What do we call this, Kirsten?
The fundamental counting principle.
Good, the fundamental counting principle. And it specifically says 2 events. You realize you could have, like in the case of the pizza further on the page, you could have 5 events. It doesn't really matter how many events, but you multiply all possible outcomes for each event together. Number 2, what's the term for the likelihood of an event taking place, Joel?
Probability.
Probability. Very good. Number 2 is probability. Number 3, the probability of an event must be between what 2 values? Probability of an event must be between what 2 values, Griffin?
0 and 1.
0 and 1. If something's impossible, class, number 4, its probability is 0. So number 4, the probability of an impossible event is 0. If it ain't going to happen, it's 0. It could not possibly happen. For instance, the odds of the St. Louis Cardinals winning the Super Bowl is 0. Now, some would argue their odds of winning the World Series is also 0. But definitely their odds of winning the Super Bowl is 0 because they don't even play football, right? They're a baseball team, okay? So they can't have any odds. Or if we were to say, what are the odds of the, let's see, who did I pick to win the NCAA tournament on that one bracket? I got UConn winning it in one bracket, and they're still alive. And the other bracket, who did I pick? I don't remember. Oh, I picked Auburn. I thought they were hot and they were playing well as a team. I'm like, they looked like a championship team coming out of the SEC tournament. I'm like, this is a team that could do it. I'm going to take a flyer on them in my one bracket, and they lost in the first round. Griffin, your team did that to me. Busted my bracket. I mean, I knew it was a bit of a long shot anyway, but you know that's how you win the tournament. You pick the long shot and get it right. And anyway, the odds of Auburn winning the NCAA tournament are now 0. They're out of it, so it's impossible. All right. What would be, by the way, class, a probability of 1 indicates what?
Certainty.
Something that's absolutely certain going to happen. Number 5, what's the name for an event composed of 1 or more, I would say more than 1, simple event? The name of an event composed of more than 1 simple event. Michael?
Compound event.
A compound event, or compound probability, right? A compound event. has more than one thing built in. The probability of this or that. The probability of this and then this. That's compound probability or a compound event. Number 6. Top of the next page. Certain keys on the keyboard are hit more often than others. Express each of the following probability notation. The probability of hitting an E. Well, how would we notate? It didn't ask what is the probability of an E. How would we notate the probability of striking an E on the keyboard, Jalen? P, and then in parentheses, a little e. What about the probability of striking a Q? Again, we don't do it very often, but the probability of a Q, we would simply write, Elaine,
P parentheses, Q parentheses.
P parentheses Q, and then closing parenthesis. What about the probability of hitting the shift key? The probability of hitting the shift key, Ben?
P, shift.
P, and then in parentheses, shift. Let's see, what about the probability of hitting either a number key or a letter key? How would I notate that probability, Corey?
P parentheses, number and letter.
I'm going to use the number sign because I'm lazy. P, number, or letter. There we go. Questions on how to use or write the probability notation. Okay. All right, let's drop all the way down now to number 11. Number 11. And read number 11 for us, Luciana.
One winner from the boys and one winner from the girls will be chosen from the class of 17 boys and 19 girls.
And they want us to figure out how many different outcomes could we have. So we got a class of 36 kids, or a group of 36 kids, 17 of them boys, 19 of them girls. How many different winner combinations, a girl winner, guy winner, could you make? At your seats. How many different combinations of winners could there be? And Luciana's got it? What you got?
323.
How many also had 323 possibilities? What do we have to do to solve this problem, Luciana?
Multiply.
Multiply
17 by 19.
Multiply 17 times 19. Make sense? One of the 19 girls is going to, one of the 19 girls is going to win. One of the 17 boys is going to win. So you multiply the 19 times 17. Number 12, read that for us if you would, Corey.
An assembly will be scheduled either for the beginning or ending of the school day during the next full school week.
When could the assembly fall? It's either going to be at the beginning of a school day or at the end of a school day. How many different ways could we have, or how many different times could we have the assembly? How many different spots are there on the schedule where we could put the assembly? You got it, Corey?
No.
No? Jalen?
2.
Oh,
No?
okay.
Did you figure it out, Corey?
14.
Not well. It's a school week. And you're very thankful you're not in school every day of the week, right? So 10, there we go. Because there's 5 different days you could pick, and for every day, you're either going to pick the beginning or ending, right? Morning or afternoon. So there's 2 possibilities. So 5 times 2 gives us 10 different places we could schedule the assembly. How many thought that through? How many put 14 like Corey kind of thought? You forgot about school week only being 5 days. Okay, several of you. All right, number 13, read that for us, Ben.
John is able to select one of 3 electives for a 6th hour and one of 4 electives for a 7th hour.
All right, how many different ways could he construct his last 2 hours of the day? This is assuming a 7-hour, 7-period school day. How many different ways could he structure his last 2 class periods, Ben?
12.
12. How'd you get that?
Multiplied 3 times 4.
There we go. Multiply 3 times 4. The 3 6th-hour electives times the 4 7th-hour electives gives us 12 different ways. How many also had 12 on number 13? Number 14. And read that one for us, Kirsten.
A project must include data about one of the 7 continents, one of the 5 oceans, and one of the 50 states.
All right, so maybe there's a kid in geography class. They're going to do a report on a continent. They're going to do a report on an ocean, and they're going to do a report on one of the 50 states to keep it close to home. How many different ways could a student put together a project? Maybe like, the coolest state would be like Alaska. That'd just be really cool because there's crazy stuff up there you don't see anywhere else. Definitely the coolest in that sense. And then like continent, like Antarctica. Antarctica seems like a really cool continent to do a research paper on. And then one of the oceans, well, how about the Arctic Ocean? That seems cool. And so they have a really cool project. Well, that's only one way to put it together. How many different ways, you make fun of me for my cool joke, how many different ways could they put it together, Griffin?
1,750.
1,750 different ways they could put the project together. How many also had that answer?
You are.
Questions? Questions on that? All right, let's see. Flip over to page 277. Flip over to page 277. By the way, while we're turning, when you figure probabilities in a particular situation, what do the probabilities have to add up to, class? 1. So each probability has to be at least, each probability has to be at least 0, 0 or bigger, has to be no bigger than 1, but the sum has to add up to 1 for all the probabilities. We've got some probability questions here on number 18, though. We've got some compound probability. Do number 18 at the very bottom of page 277. There you go. How many total morning trips are there, class?
24.
24 different morning trips that they could go on. How many different afternoon trips?
12.
12.
All right, so what's the probability if you're getting, you get to pick what your winnings is kind of at random, what's the probability of getting a hiking trip in the morning and then a canoeing trip? Well, what's the probability of getting one of the hiking trips, class? 8 to 24. What's the probability of getting one of the canoe trips, class?
6 to 12.
Canoe trips?
6 to 12.
How many canoe trips are there?
2 to 12.
2, so 2 to 12. There we go. And it says and, so what do I need to do? Multiply. Now, if it said or, I would have to get a common denominator, common consequence. It's actually the better term for it, but think of it the same way. I need to reduce this down to get 4 to 12, or bump it up to like a 4 to 24 and then add them. But it says and, so that means I get to multiply. Let's take 2 12ths down to 1 6. Let's take 8 24ths down to
1/3.
So the odds of hiking and a canoeing trip
1 to 12.
1 to 18. Somebody had 1 to 18 on letter A. Only a couple of you. Questions?
No.
Questions? All right. What's the probability of a historic tour? Those can be fun, but I think I'd rather go fishing or hiking. And then the rock climbing trip. Well, what's the probability of getting stuck with a tour class?
9 to 24.
9 to 24. I mean, it could be worse. But 9 to 24. Probability of getting to go rock climbing.
6 to 12.
6 to 12, which I'm immediately going to reduce that down to get 1 to 2 because it says and. So we're going to. I can also reduce the 9 and 24 by taking out a 3 to get 3 and 8. So we end up with a probability of 3 to 16. How many are 3 to 16 odds on letter B? We'll do the same kind of thing on letter C, shopping trip and trip to art gallery. What was your answer? We'll just jump straight to that for sake of time. What was your answer on part C, Michael?
1 to 12.
Not 1 to 12, Joel.
1 to 24.
1 to 24 should have been our answer on that one. Turn the page. Turn the page and do 22 to 26. 22 to 26 at the top of page 278. Once you're finished, stand next to your seat. So once you finish 22 to 26, pencil down and stand. Joel's finished. Michael is finished. Luciana, good. Good, Jalen. Corey almost fell. All right, good. Stuff sticking out next to your desk. That'll do that to you every time. Elaine, good. Sit up nice and tall, Ben. Good, Bryson. All right, for sake of time, have a seat. Let's take a look at our answers here. Let's see if Joel got them all. Joel, insurance company offers policies for cars, boats, and motorcycles. Not RVs, apparently. Payment plan could either be monthly, biannually, or annually. And customers can choose to have roadside assistance, or they can choose to have a discount on basic car maintenance. So, how many different plans does this insurance company offer?
18.
18, good. 3 things are covered, 3 timings in which you could pay, and then 2 extra options to add on. So 18 different plans. Then we go to the word experience. 10 letters. It comes right out and tells you, so you don't have to count, which is awfully nice because, you know, what fun is that? And it says, what's the probability of drawing an E, putting the E back, and then drawing out an R? What did you get for your answer?
1 to 25.
1 to 25, excellent. What about the probability of drawing an X or an N?
1 to 5.
Reduces down to 1 to 5. Very good. Number 25. Probability of drawing a vowel or the letter P.
3 to 5.
Reduces down to 3 to 5. Very good. And then number 26. The probability of drawing a consonant, putting that back, and then drawing out a vowel.
1 to 4.
1 to 4 is correct. Got them all. Anyone else perfect, just not quite as fast as Joel? Anyone just missed 1? Let me see, I just missed one of the ones I did. All right, any questions? We went over the answers. Do we need to see any of these worked out? Questions on these? Yes, sir, Corey?
24 and 25.
Number 24 and 25? Yeah, so as we look at this, we want the probability of an x or an n. There's only one x in experience, so that's 1 to 10. And there's only one n in experience. But remember, when it says or, we add. So if you got 1 to 100, it's because you multiplied instead of adding. You should have gotten 2 to 10, and that reduces to get a 1 to 5 answer. Does that make sense? And then on the next one, the vowel or the P. Vowel or P. Let's see, how many vowels? E, E, I, E, E. 5 to 10. And then P, there's just the one of them. And again, it says or, so we. And that's our 6 to 10, which Joel reduced down to get 3 to 5. Does that make sense? All right, good. Any other questions on that? We have quiz in our next lesson, covering probability. So by now, we should have a really good handle on this stuff, right? All right, so it should be an easy quiz for us. Get a little bit more practice in the homework this evening. Page 273 to 274. Homework for this evening is to do pages 273 to 274. The homework 1 to 16. Pages 273 to 274. Do the homework numbers 1 through 16. We'll go over that homework tomorrow, and then it'll be quiz time. And then we'll move on to a discussion of statistics. We're talking about statistics in our lesson tomorrow. Have a wonderful rest of your day. When the bell rings, you are dismissed.